All right, EEE203 midterm practice problem number 5, convolution and DT problem. So consider the following interconnection of systems, of LTI systems here. H1 of n is equal to U of n minus a delayed U of n, and that's represented here in red on our little figure. So, and then H2 of n is equal to a unit step delayed by -1 minus a unit step delayed by 1. And that's represented in blue on the figure. And we want to find A and B. And A is, what is the impulse response H of n of the URL system? Well, if you read the textbook and watched the lectures, then you'll know that H of n is equal to the convolution of H1 of n and H2 of n. And then that's equal to the sum over all k, we'll put the infinities there, of H1 of k times H2 of n minus k. Now before we go digging into this, let's go over the DT unit step. So that is, the unit step is equal to 0 for t less than 0 and 1 for t greater than or equal to 0. This greater than or equal to is important, and it's different than in CT, where it was the unit step's not defined at 0, at t equals 0. Oh, I guess these should be n's right here too, huh? So that's an n. And this is an n. And let's do a delta function real quick. The delta function is equal to 0 for n not equal to 0 and 1 when n is equal to 0. And there's a statement in the textbook somewhere, or I think he said in the lecture, that any discrete time signal can be represented as a sum of scaled and shifted impulses. So we have H1 of n. H1 of n is equal to U of n minus a delayed U of n. Now let's figure out a different way we can represent this. And here's a little table down here at the bottom left. So let's do n, and we'll do -1, 0, 1, 2, and 3. And we'll do U of n, U of n minus 2, and then H1 of n equal to U of n minus U of n minus 2. So right here we get U -1, and we look up our definition up here, and we see that's 0. And we'll have U of -1 minus 2 equal to, that's equal to U of -3, so that's equal to 0. And now here we get U of 0, and that's equal to 1. And then we'll get U of -2, and that's equal to 0. So right here we'll do U of 1 equal to 1, and then this is U of -1, and that's equal to 0. Right here we have U of 2, that's equal to 0. Oops, excuse me, that's equal to 1. And right here we have 2 minus 2, so that's 0, and that's now equal to 1. And then for 3, U of 3 is equal to 1, and U of 1, and that's equal to 1. Now for H1 of n, we just subtract this column and this column, where we subtract this column from this column. So right here we get 0 minus 0 equals 0. We have 1 minus 0 equals 1. 1 minus 0 equals 1. 1 minus 1 equals 0. 1 minus 1 equals 0. And then it's just going to continue going on like that. So we have a delta. So we could represent H1 of n as a delta function evaluated at n and a delta function evaluated at n minus 1. So let's rewrite h1 of n as delta of n plus delta n plus n minus 1. And for h2 of n, we're not going to do the table again. You can do that on your own if you can't see it, but we have a delta at n plus 1 plus a delta at n. And recall the sifting property. Now let me get my notes so I write it correctly. And that is that x of n convolved with delta of n is equal to x of n. And there's also x of n convolved with delta n minus n sub naught is equal to, yes, it's x of n minus n sub naught. So for part A up here, so we've redefined our h1 and our h2, and now we need to convolve those. So A is equal to, we have h of n is equal to h1 of n convolved with h2 of n. And let's swap out one of our functions. We'll swap this out for its new definition as we define it. So we get h1 of n convolved with delta n plus 1 plus delta of n. And then convolution is distributive, so we get h1 of n convolved with delta of n plus 1 plus h1 of n convolved with delta of n. Now, our sifting properties tell us what these convolutions are equal to. This is our sifting properties here and here. So we have h1 of n convolved with delta minus a minus 1. So that's going to be equal to h1 of n plus 1 plus h1 of n. And now we can evaluate h1 of n, or we can evaluate h1 with each one of these. So h1 is equal to delta, well, here's our definition of h1. So now we're just going to swap out, we're going to swap this out here with this right here. So we get delta of n plus 1. And now we'll do the second term. We have plus delta of n plus 1 minus 1. And then now this one's really simple. We do delta of n plus delta of n minus 1. And when we do that, we get delta of n plus 1. Simplify this, we get delta of, we have n plus 1 minus 1, it's n plus delta of n plus delta of n minus 1. And then that's equal to delta of n plus 1 plus 2 delta n plus delta of n minus 1. And that's the impulse response of the overall system. This is h of n. and I will be back for part B in a different video. Thank you.